Hi everyone, so I will be discussing Leetcode 1524 problem, number of sub-arrays with option. So in this problem we are given an input integer array and we have to return the number of sub-arrays with an option. So let's discuss what is a sub-array. So if the input array is 1, 3, 5, then its sub-arrays are 1, then 3, then this 3 would combine with 1, so it will be 1, 3 and then 5. Then this 5 would combine with 3, which would give 3, 5, and then this 5 would also combine with 1, 3, 5. So if there would have been 1, 3, 5, 4, then for the fourth part, the first element would have been this 4 only. Then this 4 would combine with this 5, so it would give 5. This this 5. So it would give 5, 4. Then this 4 would combine with 3, 5, so it would give 3, 5, 4, and combine with this would give 1, 3, 5, 4. So this is the explanation of what is a subarray. But so what is not a subarray? So 1, 5. This is not a subarray because subarray only contains contiguous elements. So this 1 is here and 5 is here. Both are not contiguous. So it is not a subarray. So a brute force approach to solve this problem would be to basically um, get all the subarrays, get all these subarrays. So all for let's say n equal to 10 raised to the power 5, total subarrays would be total subarrays would be 10 raised to the power 5 into 10 raised to the power 5 plus 1 by 2. If you don't consider this one, it would be simply be 10 raised to the power 10 by 2, which is 5 into 10 raised to the power 9. So this is a very huge number, and this is just the subarrays part. Then after that we have to also calculate their sum. So if we try this approach, it would simply give time limit exceeded. So um, a better approach would be, so I will explain through this example. So if the array is this, so the subarrays would be 1, 2, 1, 2, then this 3, 2, 3, 1, 2, 3, then 4, 3, 4, 2, 3, 4, 1, 2, 3, 4, then 5, 4, 5, 3, 4, 5, 2, 3, 4, 5, and 1, 2, 3, 4, 5. So these would be the total subarrays. Now also there would be a odd sum count and even sum count and answer. Now we simply start from this first index. So for first index it is an odd number, so it would simply be added to the answer, because in the answer we want number of subarrays with odd sum. So for this index, till this index, we have one subarray with odd sum. Now till this second index, now we have an even number, so it would not be added to the answer, but we would simply check the last element from this 2. So it is 1. Now 1 plus 2 is odd. 1 plus 2 is 3, which is odd. And if two numbers are even, then their sum is also even. If two numbers are odd, then their sum is even. If both are odd and even, then their sum would be odd, which means that uh, if we have any even number here and any odd number here, it would simply basically increase this odd sum count. Doesn't matter if it is 2 or 1, it should be even here and odd here. So this odd sum count would increase by 1. And also since 1 plus 2 is 3, so we add it to the answer. Now for this 3, again it is an odd number, so it would be added to the answer. Now this 3 is odd, so what it would do is, uh, if we combine this 3 with other subarrays which are before this, so what it would do, it would basically convert all those even values to odd and all those odd values to even. So now all these odd sum count and even sum count would be swapped. So this would become 0, this would become 1. Now we would check, now we would add what is the odd sum count here, which is 0. So it is 0 here. Now we would check what is the number before 3, which is 2. Now as explained here, odd plus even is odd, so it would be added here. 1 would be added here. Now we move to 4. 4 is even, so we would leave this one. Now, now um, we have 4 is even. So we basically we don't have any odd sum count. Basically, odd sum count before this is 0, as explained previously. So basically, would give 0, and 4 is also even, so we can write 0 for that also. But we would check what is the um, value before this 4, which is odd. So we would simply add 1 here. One correction here is that um, let's go back to this 3 only. Now for this 3, basically as discussed, 3 is odd, so this one would be added here. Now this 3 would make basically basically we would have to swap this odd and even sum count as explained here. So now since odd sum count is 0, we would basically have this, and then we would check the last index also, so which is even. So then odd plus even is odd, so we would add 1 here. Now since this odd plus even is odd, we would increase this counter to 1. Now we go back to this 4. Now for this 4, it is even. So even if we add even to odd element, it would only be odd, and even to even, it would be even. So here no swapping takes place. And also since this is even, so we would add 0 here, and since odd sum count here is 1, so we would add odd sum count here. And also since previous value, basically a value before this 4 is 3, which is odd, so odd plus even is odd, so we would add 1 here also. Now we move to 5. Now 5 is odd, so we would add 1, and odd, again as explained, odd would also, when this 3 plus 4 was for this 4 only, 3 plus 4 was odd, so this odd counter would also increase. Now coming back to this 5, this would be swapped, so it would become 1 and this would become 2. So this 1 would be added here because option count here is 1. And now we would check what is the value before 5, which is 4, which is odd, which is even, and this 4 plus 5 is odd, so 1 would also be added here, and then we would basically stop. So the total sum would be 2, 4, 6, 9. So the total subarrays with odd sum would be 9. So this is the explanation to this problem. The time complexity of the solution is simply O of n, because I am just looping till array length, and space complexity is simply O of 1, because I am not using any auxiliary space.